Have you ever woken up after a terrible night of sleep feeling less like a human and more like an extra stumbling around the set of The Walking Dead?
Oh, yeah, absolutely.
Or maybe you pushed yourself way too hard in a new workout and the next day you're walking to the kitchen as stiff as the Tin Man from The Wizard of Oz.
The classic post-leg day waddle. We've all been there.
Right. But what you probably didn't know is that while you're desperately dragging yourself to the coffee machine, trying to remember your own name, your body is quietly wrapping up this massive, highly coordinated behind-the-scenes cleanup operation.
It really is massive.
We are talking about pumping roughly 3 liters of purified fluid back into your bloodstream every
Yeah.
single day. 3 liters.
Yeah.
That's basically a large soda bottle's worth of liquid, just filtered and moved around completely under the radar.
It's a monumental physiological feat. And the wild part is that this incredible biological machinery operates without most of us ever giving it a single thought. That is, until something breaks down.
Which brings us to why we're here. Welcome to the Deep Dive Lab. We are so thrilled you're joining us today.
That'd be here.
Our mission for this deep dive is to explore your body's hidden waste disposal network. We're going to look at the lymphatic system and its newly famous, highly exclusive counterpart in the brain.
The glymphatic system.
Exactly, the glymphatic system. We have a massive stack of recent medical journals, meta-analyses, and clinical studies sitting right here on the table, and our goal is to translate all of this dense science into plain English for you.
And we really want to emphasize why you should care about this. This isn't just, fun trivia to pull out at a dinner party.
No, definitely not.
Understanding this hidden plumbing system actually holds the secret to recovering from surgery significantly faster. It offers a totally new perspective on curing chronic pain, and perhaps most incredibly, it might be the key to fighting off Alzheimer's disease.
It's genuinely wild how much this hidden system dictates our daily lives. So let's start with the body's storm drains.
I like that analogy.
When we think about fluids in the body, we usually think about blood. Think of your circulatory system, your blood vessels, like a city's pressurized water supply. Your heart is this massive, powerful central pump pushing fresh water into every single building and house. But the lymphatic system, that is the city's storm drain network.
And here is the critical difference. The storm drain network has absolutely no central pump. None.
It's totally passive.
Right. Your heart doesn't push the lymph fluid. Instead, this system relies entirely on your muscles moving, your joints bending, and even the physical act of your diaphragm expanding when you breathe. All of that manually squeezes and clears out cellular waste and excess fluid from your tissues.
I always pictured it like squeezing a tube of toothpaste. Like if you don't physically apply pressure, the paste isn't going anywhere. So what happens when we stop moving? Like if you're stuck sitting at a desk for 9 hours a day, or if you have surgery and you're bedridden?
Well, just like a city's storm drains during a storm, things go very wrong when the system gets clogged or when the flow stops. That passive drainage slows to a halt.
And the fluid just sits there.
It pools up, and that's what we call edema, or swelling. The cellular garbage, which is dead cells, proteins, inflammatory waste, it just sits there in the tissue because there is no mechanical pressure to push it toward the exit.
I actually want to dig into that surgery aspect because I always assumed that post-surgery swelling was just a totally unavoidable fact of life. You get cut, you swell up, you suffer.
That's what most people think, yeah.
But looking through our sources, that doesn't have to be the case. I was reading through this fascinating 2024 meta-analysis, and it completely changed how I view physical therapy. Can you walk us through what they found?
I'd love to. This was published in BMC, Musculoskeletal Disorders. The research team, Hongguan Liu, Kumpeng Li, and Wei Feng, they're based out of the Guanghua Integrated Traditional Chinese and Western Medicine Hospital. They wanted to see what happens to our internal storm drains after a major orthopedic trauma. Specifically, they looked at patients recovering from total knee replacements, and they examined the effects of a specific clinical technique called Manual Lymphatic Drainage, or MLD.
Now, when I hear massage or drainage, my mind immediately goes to deep tissue massage. The kind where a therapist is practically dropping their elbow into your shoulder blade, operating under the whole no pain, no gain philosophy. But MLD isn't like that at all, is it?
Not even close. MLD is highly specific, and it is incredibly gentle. The lymphatic vessels sit just beneath the surface of the skin. If you push too hard, you actually collapse the microscopic vessels and trap the fluid further.
Oh, so you're doing more harm than good with deep pressure.
Exactly. So MLD uses these very light, rhythmic strokes designed to gently stretch the skin and artificially act as the pump, moving that trapped fluid along the channels. And the findings from Liu, Lai, and Feng's analysis were striking.
They really were.
They proved that integrating MLD significantly speeds up overall recovery and drastically reduces pain after a total knee replacement.
Wait, so just by gently rubbing the skin in a specific direction, they are actively clearing out the localized fluid buildup?
That's the mechanism.
Yeah.
By manually acting as the pump, they ensure the tissues can actually heal, rather than drowning in their own inflammatory waste.
That makes so much sense. And it isn't just for major orthopedic surgeries either. If you look at the cosmetic surgery world, procedures like liposuction or tummy tucks, MLD is almost always a mandatory part of the recovery protocol.
Absolutely.
Because if that protein-rich fluid just sits in the tissue after the severe trauma of surgery, it can trigger a condition called fibrosis.
Right, and fibrosis is essentially thick, lumpy, hardened scar tissue. The body is desperately trying to heal the surgical site, but because the trapped proteins aren't being flushed down the storm drain, they basically get cemented in place. By using MLD, you are preventing the body's natural inflammatory response from overstaying its welcome and causing permanent structural damage.
Okay, let's unpack this. Because this whole idea of trapped inflammation leads us right into the realm of everyday chronic pain. And this is where my mind was genuinely blown.
It's a huge paradigm shift.
I used to think a lower back ache or a stiff shoulder was always a pulled muscle or a pinched nerve. But I was looking at this 2021 hypothesis, and they proposed something radically different.
Yes, you're talking of the paper published in Frontiers in Pain Research. This was put together by a brilliant team of researchers: Brian Tuckey, John Serbley, Meena Vithlingam, and Jay Shah.
Right, that's the one.
They proposed what they call the interstitial inflammatory stasis hypothesis. And it really challenges decades of conventional medical wisdom regarding chronic musculoskeletal pain.
So if my back hurts for 6 months straight and an MRI shows no torn muscles and no herniated discs, what is actually causing the pain?
According to Tuckey and his colleagues, a lot of chronic pain might actually just be localized clogged drains.
Wait, hold on. You're telling me that ache isn't a structural injury, it's just stagnant fluid?
It sounds counterintuitive, but the biology backs it up. It is a buildup of a highly irritating inflammatory soup. Here's how they detail the science. When you have a minor injury, or even just chronic mechanical stress.
Like hunching over a keyboard all day.
Exactly. The stress tissue releases pro-inflammatory cytokines. You can think of these cytokines as the body's chemical alarm bells, screaming for help.
Okay, so the alarm rings, and the body sends blood and immune cells to the area to fix the problem. That causes the initial swelling.
Correct. Under normal circumstances, the inflammation brings the healing factors, the tissue repairs itself, and then the lymphatic system opens up its drains and washes all the excess fluid away. The swelling goes down, the pain stops.
That's the ideal scenario.
But here is the massive catch that Tuckey's team highlighted. One of those major chemical alarm bells is a specific cytokine called TNF-alpha. And TNF-alpha has a very nasty side effect. It actually inhibits lymphatic pumping.
That is a terrible design flaw. The alarm bell that triggers the swelling also paralyzes the storm drains.
It is the ultimate biological vicious cycle. Imagine a traffic cop trying to clear an accident scene, but they accidentally block the only ambulance exit. Because the TNF-alpha shuts down the lymphatic pumping, the inflammatory waste gets trapped. It stagnates, and that stasis constantly irritates the local nerve endings.
Wow.
The tissue itself isn't torn or broken. It is just marinating in toxic, stagnant fluid, which causes chronic pain.
So what does this all mean for you listening right now? It means that if you're dealing with a nagging ache, movement, hydration, and therapies that manually move fluid aren't just nice to have luxury spa treatments. They are fundamentally necessary to break the chemical cycle of pain. If your internal storm drains are paralyzed by your own inflammation, you have to be the pump.
Exactly. You have to mechanically force the traffic cop to get out of the way. And while we have understood this dynamic in the body for quite some time, the command center of the body, the human brain, was a total mystery in this regard.
Here's where it gets really interesting. Let's transition from the rest of the body up into the brain, because the history of this is wild. For decades, literally up until about 2012, medical textbooks stated as absolute, indisputable fact that the human brain had no lymphatic system whatsoever.
It was dogma. Scientists genuinely believed the brain was a completely sealed-off fortress behind the blood-brain barrier, just internally recycling its own waste forever.
But they were wrong. Your brain does have a dedicated waste clearance network. and it is called the glymphatic system. I love comparing this newly discovered system to a fleet of city street sweepers. You know how those massive sweeper trucks only come out at 3 a.m. when city traffic is completely stopped?
Right.
The brain works the same way. Or if you're a fan of Hollywood blockbusters, think of the movie Inception. You can't just take a light 10-minute cat nap to trigger this system. You have to drop down into the deepest, most profound levels of slow-wave sleep for the real action to happen.
That is a fantastic analogy. If you don't enter deep sleep, the street sweepers simply never leave the garage. And the mechanics of this night shift are beautifully mapped out in a 2025 paper from the Journal of Experimental and Basic Medical Sciences. This research was conducted by Manual Lymphatic and Oytun Erbosch out of the EBRS Institute of Experimental Medicine.
And their explanation of how this works contains a total wow fact. I had to read this section twice. During deep, slow-wave sleep, your brain cells literally shrink.
Yes.
The physical interstitial space, the gaps between your brain cells, actually expands by up to 60%.
It is a profound structural transformation. Imagine a room packed shoulder to shoulder with people, and suddenly everyone pulls their arms in and sucks their gut in. Suddenly there is room to move.
I can visualize that perfectly.
When that space in the brain expands, it creates a powerful vacuum effect. Cerebrospinal fluid, or CSF, rushes into the brain tissue, mixes with all the metabolic garbage that built up between the cells during the day, and then flushes it all out into the venous drainage system. It is quite literally a biological power wash.
A power wash that only turns on when you are totally unconscious. But how does the fluid actually get through? Because it's not like there are open pipes in our heads.
No, it's highly regulated. Iverdi and Erbosch detailed that this immense fluid exchange happens via microscopic water channels called aquaporin 4, or AQP4 for short, and these channels are located on structures called astrocytic end feet.
Okay, we need to break that down. Astrocytic end feet. I know astrocytes are star-shaped cells in the brain.
Yes, astrocytes are a type of glial cell. They're the support staff of the brain. Incidentally, that is where the G in glymphatic comes from. It's a combination of glial and lymphatic.
Glial lymphatic becomes glymphatic. Got it. So I always picture these astrocytic end feet as tiny, highly intelligent cellular sponges that wrap themselves around the blood vessels in the brain, constantly soaking up clean fluid and squeezing out the dirty fluid.
That is essentially their mechanical function. They act as the gatekeepers, regulating the flow of the clean CSF in and the dirty, waste-filled fluid out.
And what exactly are these cellular sponges washing away? Because this is where the stakes get incredibly high for all of us.
They are clearing out daily metabolic waste, but most crucially, they are clearing out neurotoxic proteins, specifically amyloid beta and tau.
And for anyone who follows medical news or neuroscience, those names should send a shiver down your spine. Amyloid beta and tau are the main villains behind Alzheimer's disease. They are the sticky plaques and tangles that essentially choke healthy brain cells to death.
Yes. Think of them like rust on a car engine or a severe plaque on your teeth. Over time, it destroys the machinery. If you don't get deep, slow-wave sleep, those tiny cellular sponges can't do their job.
The street sweepers stay parked in the garage.
Exactly. The amyloid beta and tau proteins are allowed to accumulate layer by layer, night after night, year after year. This research strongly implies that chronic sleep deprivation isn't just making you groggy. It is actively preventing your brain from taking out the garbage, laying the foundation for neurodegenerative diseases.
It makes you look at a good night's sleep completely differently. It is not a luxury. It is a critical, non-negotiable cleaning cycle. And knowing that we only discovered this a little over a decade ago makes me wonder who is actually leading the charge to figure this all out. Because it seems like every neurologist on Earth would drop what they are doing to study this.
You're absolutely right. And it triggered an absolute gold rush in modern neuroscience. Everyone is racing to understand this system because the implications for curing Alzheimer's and Parkinson's are staggering.
Which brings up a really interesting perspective on the science itself. I was looking at this 2025 bibliometric analysis, which, for those who might not know, a bibliometric analysis is basically a massive data map. It looks at every single study published on a specific topic to see where the trends are.
Right, it tracks the momentum of the field.
Exactly. This one was published in Frontiers in Aging Neuroscience by Yunian Wang, Kangsheng Liu, Fan Ye, and their team at Hubei University of Arts and Science. They mapped all the research on the glymphatic system from 2012 to 2024.
And the data they uncovered reveals a fascinating global dynamic in how science actually works today. When you look at the sheer volume of original research articles being pumped out, Chinese researchers are leading the world by a wide margin. They're producing an incredible amount of raw data, conducting countless original studies and building the sheer mass of literature we need.
But the Wang, Liu, and Yi paper points out a brilliant contrast. While the highest volume of papers comes out of China, the most profound impact, measured by how often a paper is cited and used as a foundational building block by other scientists, comes from researchers in the West.
Yes, specifically Denmark's Maken Nedergaard, who is essentially the pioneer of this entire field. Her papers average a staggering 266 citations each.
That number is practically unheard of in a field this new.
It really is. It means her work is the bedrock that everyone else is building upon. And the analysis also highlights U.S. researcher Jeffrey J. Elif as another massive powerhouse driving the foundational understanding of the glymphatic system.
It paints a picture of this massive global collaboration. You have massive rapid data generation on one side of the globe and highly influential paradigm-shifting foundational theories on the other. Everyone is throwing their weight at this.
What's fascinating here is that the global scientific community realizes the clock is ticking. Aging populations worldwide mean neurodegenerative diseases are skyrocketing.
Yeah.
If we can figure out how to optimize this brainwash system or repair it when it breaks down, we might actually change the course of human health.
Okay, so we have the body's storm drains clearing out painful inflammation, and we have the brain's night shift clearing out Alzheimer's proteins. But what is actually powering all of this machinery? The pumps and the cellular sponges don't just run on magic.
If we connect this to the bigger picture, we have to look at the cellular engines.
Okay.
And there is a phenomenal 2026 systematic review published in Frontiers in Neuroscience by T. Pihala, V. Kiviniemi, and Mika H. Martikainen. They investigated the direct, undeniable link between the glymphatic system and mitochondria.
Mitochondria, the powerhouse of the cell. I think that is the one phrase everyone universally remembers from high school biology.
It is. But what Pihala and the team found is a profound, almost fragile, biological interdependence. You see, the glymphatic system requires a massive, sustained amount of energy to create that vacuum effect, to expand and contract the interstitial space, and to operate those AQP4 water channels.
And that energy comes directly from the mitochondria.
Exactly.
So if the mitochondria fail or become dysfunctional because of aging, poor diet, or environmental stress, the garbage trucks literally run out of gas.
Precisely. If the powerhouses don't provide the energy, the glymphatic flow grinds to a halt. But remember the vicious cycle we talked about earlier with the storm drains and the pain? It happens here too. It goes both ways.
Yeah.
If the garbage trucks stop running, the toxic metabolic waste builds up rapidly in the brain tissue. And what does that toxic waste do? It poisons the mitochondria.
Oh, wow. So if the power goes out, the trash builds up. And the trash itself destroys the power plant.
Exactly. The health of your cellular engines and the efficiency of your waste disposal system are entirely locked together. You cannot have healthy mitochondria if they are suffocating in metabolic trash. And you cannot clear that trash if your mitochondria aren't generating the immense power needed to run the fluid pumps.
That is just incredible. And a little terrifying, but mostly incredible. Okay, let's zoom out and summarize this deep dive for you because we've covered a massive amount of biological real estate today, from glowing chemical alarm bells to brain street sweepers. Here are the 3 key takeaways you need to remember from all of this research. First, the lymphatic system is your body's passive waste removal network. It does not have a central pump, so it requires your movement. And when things get stuck, techniques like manual lymphatic drainage are scientifically proven to clear out painful, stagnant inflammation and significantly speed up recovery from trauma and surgery.
Second, your brain has its own highly specialized, exclusive version of this, the glymphatic system. But it acts strictly like a night shift. It only activates its biological power wash during deep, slow-wave sleep. If you aren't sleeping deeply, you aren't washing away the toxic proteins that are known to cause Alzheimer's disease.
And third, the health of your cell's powerhouses, the mitochondria, and your body's waste disposal network are entirely dependent on each other to survive. A failure in one guarantees a failure in the other.
If there is one big picture takeaway from all of these sources, it is that your body is a deeply interconnected metropolis. We spend so much of our time thinking about the command center, the brain, and the engine, the heart.
Right, we obsess over cardio workouts, brain training puzzles, eating right.
But the waste management department is truly what keeps the entire city from collapsing. If the trash isn't taken out, the city dies, no matter how strong the engine is.
It absolutely makes you appreciate the unsung heroes of your anatomy so much more. Thank you so much for joining us in the Deep Dive Lab today. If you found this journey into the hidden plumbing of your body as fascinating as we did, please make sure to subscribe to the channel for more incredible journeys into the science of us. We have so many more stacks of research to unpack with you.
But before we go, this raises an important question. A bit of a cliffhanger for you to mull over as you go about your day.
Oh, I love a good cliffhanger. Lay it on us.
We know that scientists worldwide are currently mapping exactly how this brainwashing system works during deep sleep. They are studying the brainwave frequencies, the fluid dynamics, and the exact mechanics of those astrocytic water channels.
Right, the global gold rush we talked about.
So if we know the precise mechanical and electrical triggers, could we one day design a technology, maybe a sort of targeted, non-invasive vibration device you wear like a headband, or a pacemaker for the brain that artificially triggers the glymphatic system? Could we literally flip the switch and wash away Alzheimer's-causing proteins while we are sitting on the couch, wide awake, watching a movie?
No, that is a sci-fi future I desperately want to see become a reality. Until next time, keep diving deep.